What is up, Team Vuong? Welcome back, and today I'm going to be talking more about math. This video is for you kids, but also is for your families as well, if they are curious about the way that we do math nowadays. Of course, it's very different than how it used to be done. But the thing is, I really like how math is being taught nowadays because it's helping you guys expand more on your strategies and how you think about math in a more kind of flexible way. It's not just one way to get to the right answer. And some strategies are more efficient than others. So it brings in a lot of critical thinking skills on how to pick a strategy that is the best one and the most efficient one so that you guys can eventually hopefully do math in your head. Because what I found was that back then when I was doing math, I was very confused because there wasn't very much of the why about why we did a certain thing, and we're just made to do it. And sometimes, yeah, it could be the fastest way, but it's not going to help you think about math in a deep way, and build your number sense so that you're able to manipulate numbers. So I really like how math is being taught nowadays, and I became a better mathematician after I started to teach elementary school. And it helped because I learned how to teach math the new way, starting in second grade to third grade to fourth grade. So I have a very good foundation of all those skills. So I believe very strongly in it. Yes, it could maybe seem like more extra tedious work, but the thing is that once you learn how to do all these different things and learn the concept behind these different strategies, then later on you can move on to even more quicker and more efficient strategies. And like I said, maybe be able to do this in your head. So today I'm going to be talking to you guys about a major cluster in fourth grade, which is multiplying numbers with more than 2 digits. So in third grade, you guys did a lot of one digit by one digit multiplication, which is super important that you guys learn those facts and commit them to memory. Because when you're doing harder, more complex problems, you're going to be able to kind of draw back and not have to focus too much on the single digit multiplication. And that's just going to make things a lot quicker for you and more efficient for you. So commit it to memory. It's not very big that you memorize your facts anymore, but the thing is you have strategies on how to learn those facts. But as you're doing them more and more and more, you'll start to put those into your memory so that when you look at what 3 times 5 is, you're going to know that that's 15 and not have to, in your head, do equal groups. You don't have to repeat or do repeated addition or whatever. So single digit multiplication, commit that to memory, most importantly. Okay, so today I'm going to be talking to you guys about the area model of multiplication. I brought home some manipulatives to kind of show you what's happening with the numbers. And yeah, come along with me. So what we have here, I'm going to take it back to just a simple one digit by one digit multiplication. When we're looking at 4 times 3, back then in the past, we would learn that 4 times 3 is 12 and just memorize it, not really understand what's going on with the numbers. But if we were to use the tile array model, we can do, and we can build out a 4 by 3 or a 3 by 4 and understand that 4 times 3 is kind of like saying there are 3 rows of 4, 1, 2, and 3. Okay, of 1, 2, 3, 4, or it can be 4 rows of 3. Okay, this one, this one, this one, this one, and 1, 2, 3. So understanding that when you think of multiplication as these numbers being the dimension of the array, we can understand that the area of a 4 by 3 is 12. Okay, if you don't believe me, you can count each one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I like to think of it as making it more efficient and aligning everything up so that we have rows and columns. So once you understand the gist of this, and understand the concept of multiplication being an array, we can move on to the area model. Okay, so the area model, now instead of having all these little small units being drawn out, I can just draw a rectangle, not to size, and know that a 3 by 4 is going to equal an area of 12. Okay, notice how I didn't draw in any of the tiles, because yes, I could sit here and I could spend my time drawing out a 4 by 3 or whatever, right? But instead, I can understand that in a 4 by 3, the answer is 12. Okay, there are 12 units inside of it, even though you might not be able to see it. Okay, so the basis of the area model multiplication is understanding that this right here can be split up into smaller partial products, meaning smaller arrays, hidden arrays within this big one right here. Okay, so for example, let's just say that I do not understand or do not know what 4 times 3 is. I can take this 4 by 3 and I can break it up. I can break it up maybe like right here. Okay. Now I have 2 different arrays right here. This is still a 3 by 4, just like how it's a 3 by 4, just like how it's a 3 by 4. But now instead I am cutting up the array so that it looks like this. So I have 2 smaller arrays. Okay. Meaning now I'm going to change colors, the pen, so you can see. So now I have a 3 by 2 here, and then a 3 by 2 for this one. Okay, don't believe me? Look back at this model. There is a 2 by 3 and a 2 by 3 right there. Okay, so with this, if I know a 3 by 2 is 6, and I know another 3 by 2 is another 6, I can understand that a 4 by 3 can be split up to the following equations of a 3 by 2 and a 3 by 2. Okay, then from there, we know that that's kind of like saying 6 plus 6, which equals a total of 12 units. Okay, I always make sure that the numbers are not naked, meaning that naked numbers really don't give us very much. And right now, this problem is a naked number calculation. We don't know what this 4 times 3 is, so you can add the context yourself. Like, I don't know, there's a box of crayons that have 4 rows of 3 crayons in each row, or I made 4 goodie bags and placed 3 Jolly Ranchers into each bag. I don't know, whatever. But whenever we don't know what the unit is, I just put a U in terms of just saying that that's the unit. Okay. Oh, sorry. Actually, I'm going to say square unit. Okay. So that's the basic gist of what I call partial products. Partial products. Because it's going to be very key in when we multiply multi-digit numbers. Okay, so before I move on, just so that you guys can see one more example, I'm not going to really solve it. I can also take this and make it a 3 by, I don't know, 3 by 4, so I can just go like that. Okay, this is still a 3 by 4. It's just split up differently, and I split it up into 4 different partial products. So if you look here, it's kind of like me taking this 3 by 4, and then I split it up this way so that it's the dimensions of a 2 by something and a 1 by something, and then I split it up even farther like that. and then like that. So as you guys can see, this one right here, I did not add any more units to it. It is still a 3x4. I just split it up a different way. I split it up into a 2x3 right here. I split it up to a 2x1, which is this one right here. Okay. Split it up to a 1x3, which is this one, a 1x3. And then I split it up to a 1x1, which is this one. Okay. Either ways, you're going to find that this is 6 plus 2 plus 3 plus 1, which is going to equal 12. All right. So that's kind of an overview of what partial products are. So now let's look at how it works when we talk about a bigger number. So the area model multiplication with a 14 by 22. Okay, so I'm going to build a model of it on this side, just so you guys can see. I'm going to actually turn this over, and I'm going to build on here while I draw the model of it on this side. Okay, so when I think of a 14 by 22, it's just kind of like thinking about this thing. Like you have to remember that I could sit here and I could take every one of these tiny units and build a 14 by 22, 14 rows of 22 in each row. But that is not very efficient. So we're going to use what we just learned with partial products to break this problem up. This is a naked number calculation right now because we don't know what the units are. Okay, but what I'm going to do is that I am going to make a 14 by 22. So hold on, let me figure out how to do this. So I might draw out my square, my rectangle, sorry. Okay, understanding that this right here is a 14 by 22. Do I put 14 here or do I put 14 here? I would say that this right here is 14 and this up here is 22 because the length or the width of it is longer, so it doesn't make sense for 14 to be on the longer side. Okay, so from there on out, I am able to now split. First of all, I don't know what 14 times 22 is. That's not like something that I memorized. So I have to break it into pieces of things that I can easily solve. So what I like to do is I like to take 14 times 22 and I like to take those and break it up into base 10. So I like to break it up as a 10 and 4 and a 20 and 2 is how I like to do it. Some people might do it in a different way, just like how you saw with this one right here. There's so many different ways of breaking it apart, but the most efficient way is thinking about it in base 10. So I can take this and I can do a cut right here. I can't do it in the middle. Some people might teach you how to do the window method where you just split it right down the middle, but that wouldn't make sense either because that wouldn't be to scale. So I might do this and I might do something like that. Okay, so up here I have 20 and a 2, and on the side I have 10 and 4. Okay, so that's how it looks like. If I had to build this out, then it's going to look something like this. I'm not going to take every single one of these units and build a 14 by 22 because that would take way too long. But I am going to use these mats representing my 100, this representing my 10, the strip, and then this representing my 1s. Okay, and I'm going to build a 22 by 14. So this one right here is a 10 by 10. I have to keep going so that I get 22. Cool thing about, hold on, let me make sure things are underneath. There you go. Okay, so the cool thing about this is understanding that once I place down these base 10 mats, all like the little units, the area is already in there. So right now I have a 10 by 20. Okay, 10, 20. I need 22. So I'm going to continue adding on. Like that. Okay. So now I have a 10 by 10, 20, 21, 22. Okay. There are a total of 22 columns going across, or 22 in each row right now that I have. Okay. But I need a 22 by 14. So is it possible that I add another one? That wouldn't work because that would be a 20 by 22. So I'm just going to use these small strips and I'm going to place them. That's an 11 by 22. I need 14. Okay, so I'm going to add in, that's a 12 now on this side. Now that's a 13. And now finally, that's a 14. Okay. And I'm not done yet. I have to make sure I add in the rest of the array. So I'm going to make sure I take... Yes, we can stand here and fill it in with all these small ones, like I like to say. But that's not efficient, so let's not do that. So why not do it in tens? So I'm going to add in a 10 here. I'm going to add in another 10. If I can, like, pick them up. There you go. Another 10 here. Another 10 here. Lastly, a 10 right here. So guys, if you see this, I have this so far, and I need to fill in the rest of it. So let's do it with ones because nothing else can fit there. A mat won't fit there, a strip won't fit there. So we have to fumble with this. Okay, so the reason why I'm building this area, it's not the area model, this tile array model, is just to show you what is happening right here. Okay, so there's this one, almost done here, guys. This one. And I'm also filming this with, like, it with one hand. So that's why I might kind of struggle a little bit here. Okay. Lastly, I need one more. Come on, there you go. Guys following me so far? Okay, so just to check and make sure, do I have a 14 by 22? This is now a 10, 11, 12, 13, 14. There's 14 rows going across. Okay, and there are 22 up here. 10, 20, 21, 22. Okay, 22 going down that way. Okay, so now let's go on to here. And you can see that I now split it up to a 20 by 10. This piece right here is a 20 by 10. Which, on this piece, it's kind of like saying I'm going to split this up right here. That's a 20 by 10. Okay? Right here, this piece right here is a 4 by 20. I'm going to write 4 by 20 right here. Which is pretty much this piece. It's a 4 by 20. Right here, I'm going to say this is a 10 by 2. 10 by 2. 10 by 2, if you can look here, where do you see it? It's right here. That's your 10 by 2. And then your last piece right here is the smallest piece, and it is a 4 by 2. 4 by 2. Which, if you look here, that's a 4 by 2. So really, you have something that looks like this. Okay, 4 different pieces that you are that you're cutting up, and then we can figure out those pieces, those small pieces, quite efficiently. And how do we do that? Let's see. So I know that in my 14 by 22, and I'm going to write out all the steps here in an equation. Okay, so I know that it's going to be a something by something plus a something by something plus another something by something plus another something by something. Okay, and I'm just going to fill that in. I have a 20 by 10. I have a 10 by 2. I have a 4 by 20. And I have a 4 by 2. Okay, those are all my partial products. Okay, next, I'm going to figure out what those are. Okay, I might make a video later to talk more about what does it mean to append the zero, because it's not like how we learned it in the past was how to drop the zero, but really it doesn't mean that. But I'm going to just kind of glaze over it right now. But a 10 times 20 is like saying a 2 times 1, and 2 times 1 is 2, but then it's 100 times more than that. So 2 times 100 is 200. Okay, and we append 2 zeros. Okay, so that's this 200 right here, which is this piece. If you don't believe me, count one by one, but I would not. Okay, so right here is your 10 by 2, and we know that as 20 is like 2 times 1 is 2, but 10 times more is 20. Okay, so adding a 20. Okay, next, so right here, this is 20, 10, 20. Okay, now this last piece, or this next piece, is a 4 by 20. 4 by 20 is like saying a 4 times 2, which is 8. But then that's 10 times more than a 4 by 2, so that will be 80. Okay, we append 1 0. So 80. And lastly, we get our 4 by 2, which is a 4 by 2 right here, which, if you know your facts, is an 8. See why it's important to know your facts, so that you can just get it like this, and not have to go, oh, kids, see 2, 4, 6, 8, right? Okay, so then from there, we have all these to add, and the cool thing about base 10 is that you can add them pretty quickly, because knowing 80 plus 20 is 100, and adding that 100 to this one, that will be 100 plus 200, that's 300. 300 plus 8 is 308. So your answer is 308 square units, okay? Or 308 cats, or 308 candies, or whatever, okay? So that is your answer right there, okay? So just so that you guys can see, these are my partial products. 10 times 20 is 200, right here. 10 times 2 is 20, is right here. 4 times 20 is 80, which is right here. And then 4 times 2 is 8, which is right here. And I split all those up so that I arrive at my answer. All right, guys. So that is the lesson for today. This is just one strategy for multiplication, but it's one very important strategy that's being taught now. I know some families might be like, why can't we just do the regular algorithm where we go 14 and we just line it up times 22, and then you go 4 times 2 is 8, and 2 times 1, which is not really a 1, is 2. Then you come down here and you add a 0. How does that 0 get there? Then why do you do this? 4 times 2 is 8, and 2 times 1 is 2. Okay, and then you add these together, 28 plus 280, and get 308. So you get the same answer, but this one right here is more procedural, and they will learn it. It will be taught later on when you really master what's going on with the numbers. But right now, really focus on the area model, and hopefully families, you are watching this and you're learning it along with your kid. Yeah, guys, that's about it. If you guys have any questions, please add it to the comment box below. Share this with other people, because there's a bad stigma right now about the area model, and like people are comparing it side by side with the algorithm and how we're doing it nowadays, the new way of math, and just kind of saying how it doesn't work and it's inefficient, and like, why are we teaching our kids this, blah, 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 blah. But really understand, guys, that this is, there's a lot of benefits to learning how to do it this way before we start learning it the shortcut way. Okay, so that's all there is for me. I will come back next time, and I think what I will do is talk more about what it means to append a zero and not just drop the zero, and maybe show you other different multiplication strategies as well. So that's it for me. I'll talk to you guys later. See ya. Peace. All right, just kidding, I'm back. So, before I go, I want to leave you with 3 problems so you can work on them. I want you to solve these in this way, okay? I want you to take it and I want you to break it up into their partial products, and I want you to label it and write out your equation this way. This is the same as this array plus this array plus this array plus this array, and then go down to the next row, do an equal sign, and then solve for the areas of each of those arrays. And then finally, at the very end, you can write down your answer right there. And please write square units, because I'm not going to give you any specific unit to go along with it. It's just going to be naked numbers. Okay, so your problems are these. Where are we? Okay, you guys can see it. The first one is 32 times 51. The second one is 96 times 7. And the third is 6,258 times 4. Can you solve it this way with the area model? Not the algorithm. Okay? All right. Have fun.